Yeah, we waiting for you to connect. We'll be talking today about stop calling everything an AI agent, looking at automation and autonomy, the context of artificial intelligence. So we're going to do some deep technical dives today. So wherever you are, maybe good morning for you, evening for you, night for you, afternoon for you. Here I am in Texas. It's good afternoon. And so I'll be doing some very deep technical dive into automation and autonomy when it comes to artificial intelligence. These days in the industry, we see people calling anything AI agents. I want to give some clarity today to that. So share the link, invite your friends to join us. If you are joining us from YouTube, joining us from Facebook, from LinkedIn, let's look at some of the technical stuff. Okay, and so we give it some time to allow people to join us. Okay, give you some time to join, and then be able to give some technical dives into it. So waiting for you to join, invite your friends. It's going to be really, really interesting as we discuss about stopping stopping calling everything agent. So wherever you are, we join the queue and then we'll learn. So we'll be discussing shortly. Wait for some people to join. Can share the link with your friends. We'll be doing some deep technical dive shortly um, into this subject. You know, a lot of people are calling everything AI agents. So I want to give you some context to the technical part of all that is happening. That is like a game changer today. So wherever you are, you can invite your friends as we start shortly, where we give you some deep technical dive into these things. Okay, give you serious technical dive into some of those things. So I'll be talking about stopping um, stopping stop calling everything AI agents. Okay, and this is going to give you clarity. So wherever you are is place you want to really be. You can join us on Facebook, on LinkedIn, on YouTube. I'll be sharing that as quickly as possible. You know, you can join us, and then we'll talk about it. Talk about it in a moment. Okay, and so wherever you are, can share with your friends. Okay, and we discuss it. Discuss the this great subject in terms of giving you some technical detail. Okay, so we can start now. I'll be talking about stop calling everything, okay? Everything AI agent, right? So I'll look at automation and automation versus autonomy, right? In the concept of artificial intelligence. By the way, my name is John. I'm the chief solution architect here in MVIT, Texas, where we build, we innovate, we train, we guide other people and mentor other people coming into AI. In the AI industry today, there is what we call the ROI crisis or the return on investment crisis in the AI industry. And the key reason for this is that 80% of AI projects fail to move from proof of concept to production. Yes, you can share idea, talk about idea, but 80% of AI projects today, they are failing because from moving from proof of concept to production. And 40% are cancelled in terms of cancellation due to spiraling infrastructure costs, the cost of infrastructure, and then low utility, low utilizations. And the root cause of this is that there is a confusion between around simple automations and through agency, okay, or what we call the AI agent. The AI project failure crisis is as a result of what I call a data driven alarm, in terms of either moving from proof of concept to production and then cancellations as a result. And in fact, 40% cancellation rate is due by 2027, right? That means AI projects are doomed to fall as a result of this a kind of confusion. And those are the things that I want to quickly discuss about. The There is four categories of discussion, right? So what is an agentic AI, by the way? As you see in the diagram, you see that we have the LLM chatbots, which is the large language model chatbots, like you have your basic ChatGPT today, the Gemini, the Cloudy, and all those, or the Chrome from SAI, right? So uh, you need to understand that those are not AI agents, okay? The chatbot, like you have the chat GPT, you write a query and then you get an answer. Okay, the answer is the query is you write or you ask question in form of what we call a prompt, right? And then this question is taken in by the large language model that is built, and it provide an answer. And then there's what we call RPA, which is the robotic process automation, right? So in this context, you write a query and a script, and this script trigger information to happen to produce an output. Or there is what we call the RAG, that is the retrieval augmented generation, which is like you build a knowledge base, maybe document, and then you can ask questions into those documents. These are not AI agents. When we talk about the agentic AI, we're looking at system that plans, system that is act like a worker, right? It plans, it acts, it executes tasks and then it even keeps a kind of, it also learn and heals. Okay, those are the things. So when we talk about the chatbots like the GPT and those things, the interface, you ask on the interface and then you get an answer. It doesn't take action. Okay, and then but in terms of the robotic process automations, you see you have a script. You say, for instance, if S then Y, right? So it breaks on the edge case. But and then we have the retriever augmented generation, which we call the rack system. It has a kind of memory which is the knowledge base, actually document. So it fetches information from this document, and then it does not plan, it does not add, it provides a result. But when we come to the agentic system, okay, this side, the agentic system, it has a worker, it collaborates, it works, it can remember, it can work with a lot of things, it plans, it adds, and then even execute, use other people like tool to, and then even learn as well. And so again, remember, we are talking about stop calling everything an AI agent. And so understanding automation and autonomy system is very, very important, because it causes a lot of problem in the industry. And so when we're looking at the large language model chatbot, they are interface, okay, not a worker, right? It's a gender is a worker. You ask and they answer, and then they are done. So the limitation for the chatbot that you have, or the large language model chatbot that you have today, no decision making, no tool execution, and no outcome ownership. It doesn't take ownership. But when you come to the agentic world, it takes ownership, similar to human being, being responsible for the action that are taken. Okay, and so the chatbots example are the ChatGPT that you have, the Gemini Basic, and the Cloudy that you have today. So the simple large language model chatbot architecture, it has a follow a kind of a linear path, right? Where you have a linear input process and the output flow with an explicit limitations. And so you write a query, and then which is a prompt. You define the context and what you want to get, and then it searches and processes this input, generated a text based on the trained data, and then give you an output. But remember, there is no tool involved. It doesn't involve third party to do anything. There is no memory, okay? It doesn't remember anything, and then it doesn't do any planning or execution. Then when it comes to the what we call the robotic process automation, which has been around for a while, or the RPA, these are assembly lines, right? That this the assembly lines does not take decision, not decision makers like the agent, AI agent. And then of course is strict script, zero flexibility, right? So, for instance, you can say if invoice total is greater than or equal to 5,000, then send an email, or else approve, that kind of thing. So it sticks to the boundaries, is bounded by a kind of a script. And then when they hit an edge, because of the definitions, they breaks immediately. And so we have the UI part, the automation everywhere. We have the Microsoft Power Automate. Those are robotic process automations that even people are bringing to use today as well, similar to the way you say. So it can be used to automate invoice processing using what we call the assembly line, like you see. So when you receive an invoice, it extracts some information, probably the amount, and then automate. And it keeps that to do a kind of it follow a kind of a pattern. But again, they are limited. Then you come to what we call the rack system. In other words, the retrieval augmented generations, which is earlier last year and all that, you see most of that being built, right? So their memory, not they of course they remember a few things because you have a library, right? And in this library, they have memory, but the memories, of course, they are not intelligent. They fetches data, pass this data to the large language model, and then they ask questions. So it retrieves information from the knowledge. It has uses capability for what we call vector search, and then generate like a kind of answer. So they great for support and document, but they don't plan, they don't act, they don't execute the workflow, right? So you have a lot of like Veritas, AI, chat, Azure search, and all those type of things. So you the user queried, and then it has an embedded model, okay? And these models are attached to what we call the vector database. And so in this vector database, connected to the knowledge base, which is your excluded or a kind of excluded or dedicated knowledge document archive that you have for them to search. They retrieve information based on the context by the helps of the large language model and provide a response. Okay, so that is that. Then we come to the agentic system, which is what is happening now very well. This 2026 going to see a lot of agentic system, and as we get along, you see a lot of that. Most of the application that will begin to behave autonomously, okay, independently, just like human being, and so which is a true agent. And here, a true agent isn't a tool; it is a digital worker, like human being, right? Because it plans. That means it figure out what to do first, what data to get, and then it also acts, right? It acts based on that. It call maybe API, update CRM, trigger workflows and all that. And then again, it also remembers, right? It remembers, there's what we call the LTM, that is the long term memory. And then it learns from feedback that it has got before. And then again, it collaborates because there could be, there's what we call multi-agents, many type of agents. It's like a team of financial expert, team of business expert, team of engineer with different capability, and you work together to be able to fulfill a specific goal. And that is the context you need to look at it, right? So automation follows order, right? Automation follows order, autonomy figure them out. So you must understand. And by the way, you could combine uh, RAG, bring those type of automation into an agentic environment. Okay, so you could have a coding agent. These days we have agent that can code, write software like a software engineer, if not even if more faster. We have citation agent as researchers, uh, different type of agent that can plan, that can act, and it also has orchestrator, right? That can do many things. Those retriever agent, those discovery agent, and they collaborate together to make sure that things are being fulfilled. Now, let me talk about the orchestrator, okay? That is the brain of the operation. The orchestrator is the brain of the operation. So here in a multi-system, multi-agent system orchestration pattern, we have this, it could centralize, decentralize, hierarchy, and then federated. And so in terms of the centralized, it has a single point of control, okay? And then decentralized, it's a peer-to-peer collaboration. So you support me, I support you, peer to peer. And then hierarchy in terms of who does what, okay? Dependence, right? So it's a take command structure where or you get order from above to execute that kind of thing. And so you just need to look at it in that context. Federated is working just like a local government, state government, that kind of. So independence with coordinations. Okay. So this is very, very key in an agentic system. Again, the orchestrator, that is the brain of the operation. It manages the who, the what, and the when. And so here there is what we call semantics routing, where there is it does direct query to the right special list agent. Just like when you have a task to do and you have in a big team, you say who is the right person that can perform this job, and then you have some criteria of determining who is the right person, maybe based on their experience, based on how quickly they do a job, that kind of thing. So you use what we call semantics routing to be able to do that. Then number two, there is dynamic planning. And so here it breaks the complex tasks, complex goals into executable tasks, right? Steps, in other words. So similar to the way human being plans, when you want to fulfill something, you break them into different segments and steps. And so the agent orchestrations help us to do semantic routing. It helps us to do dynamic planning, which is breaking the complex goals into executable steps. And then it does what we call state management. That means it maintains context across the long running workflow. So the pipeline keeps running and it measures that. And then of course, there are major ecosystem players like the Google Veritas AI, AWS, Bedrock, NVIDIA, NIMS, the LangChain, the Meta, Llama Stack, the Microsoft Autogens that you can use to do a lot of orchestrations of multi-agent or agent system today. Then there's what we call the reason plus art, that is ReAct framework, right? So here what happened is that the iterative loops, it follows what we call interactive iterative loops. And so what happened is that there is a think, there is a do, there is observe, and there is repeat. And so say for instance, let's look at this iterative loop, for example. So you have a thought, I have an action, observation, and a thought, right? So I need to find the stock price. Let's say you are trading, you need to find the stock price. And so the tool, it calls the tool that gets the stock price, maybe NVIDIA stock price. And then the observation is a price. How much is it? It gives you the observation. Now the thought is that now I can answer the user. So this is the iterative loops. And so the pro of this is that it is accurate. That means there is a it does what we call self-correct error in real time. But again, the issue with it is latency in terms of delay. It could be slow, maybe because of the serial steps that is involved in terms of executing the steps. So there is what we call the ReAct. That is, and remember, there is the ReAct looping is an iterative problem solving. It's solve it in form of iterations. Okay, and then there is a thought where you think, you do, you observe, and repeat. So you follow a kind of a thought process. Okay, where of course the way it is, there is a thought, there is an action, there is an observation, and it continue that pattern. And where you need to terminate, you terminate. Where you need to continue, it also continue that pattern. Number two, there is what we call rework. That is reason without observation. Reason without observation. Here we look at the efficiency engine, where it decouples planning from execution. Decoupling of planning from execution. And it involves, in terms of architecture, it involves three layers: the planner, the worker, and the solver, right? So the planner generates the full plan upfront. It's like in a project when you have something to do, you create an execution plan with placeholders, who does what and who will do what, even when, right? So, and this follow with all reasoning upfront, the execution, and then the worker does the execution plan with actual tool, and then of course with the placeholders and everything. The problem solver synthesize your final answers and then combine all the results with all that, similar to the way you can see. So in terms of performance comparison, these are the two methods that can be used today for 80% cost reduction, the way we implement those things. And so the planner generate the full plan upfront. The worker execute the two in parallel where possible, and then the solver, of course, synthesize the output into a final answer. So this significantly reduce token usage and latency compared to the other method that I have shared earlier, which is the REACT. Now let's look at the production infrastructure. Okay, when we talk about agentic system or design today, there are things you need to put in place. I told you earlier that 80% of AI projects fail to move from prototype or proof of concept to production as a result of high cost of the infrastructure, at the same time simple misunderstanding between automation and autonomy. And so it's not just an LLM. LLM means large language model. Okay, it's a platform, right? So if you are moving to production, it's a platform. And when you look at platforms, you must consider in the AI project today, you must consider the compute requirement, right? The computer requirement in terms of computational requirement, the inferences that you need to use, right? Like we have the NVIDIA, the AWS TPU from Google, and all those type of things at the compute and inference level. Then at the model layer, you have the OpenAI GPT-4, Gemini 1.5 Pro, and then all the Anthropy. Those are all the Llama, right? Different type of or Mistral, different type of models that are out there that you can look at it based on which solve your problem. So all that must be considered when you begin to think about your infrastructure. Then the orchestration in terms of LangChain, Microsoft AutoGem, IBM, and all those type of things. Then again, there is a vector memory in terms of the Pincom, the wave, the Wavelet, and then the Veritas AI search. These are used for vector memory. So in terms of layer one is the orchestration, which is the foundation, is the container orchestration side of it, and where you have all those 13, either from Google, from Microsoft, and the rest. Then you have the state and the data layer, which is the where you manage your state, right? So either using Redis or the vector database and the messaging queue, the Kafka, and all those type of things. And then you have the orchestration level. Use the Tempora, the Airflow for task scheduling, or the service discovery, the console, various type of tools that are out there. Then the agent layer itself, you have the orchestrator that I mentioned that have sub-agent and the tool integration based on what you want to trigger to answer those things. Then the observability level, which is your distributed tracing, your monitoring, and logging. And so all these provide a good way of implementing your production infrastructures as of today. Let's look at the automation and autonomy, right? When it comes to artificial intelligence, automation, doing things right, follow a pre-defined script perfectly every single time. That is automation, right? So it does a trigger process, and If there is a failure, it stops on error, right? So there's an explicit event, event, and there is a linear script it follows, and then it stops an event based on trigger, or what we call the TPF. That is a trigger, process, and failure in terms of automation. It follows a predefined script to perfect at every time. But in the terms of autonomy, right, which where we have our agentic system today, it does things right. It figures out the best path, right? In networking, there's what we call the shortest path, right? The best possible, the best shortest path, or things like that. So it follow a path. It figures out the best path to achieve a high level goal, similar to the way human being is thinking. When you have a job to do, you think, what is the best path for me to get this job right, to do it quickly, to meet my time? And there are many factors that you consider. So that is a simple way that when we talk of autonomy today, that it does this thing. So in terms of TPF here, TPF here, in the autonomy industry, there is a high level goal that is set, that it uses the high level goal to do a trigger, and then there's what we call dynamic planning that I talked about earlier, and then it does self correct. It's correct itself. Let's look at decision framework. Okay, decision framework in terms of when you use R uh, use RPF, that is robotic process automation. It doesn't don't over engineer it. By the way, it is the process strictly deterministic. That means if S, then why, right? That kind of thing. Then, but in terms of rack, which memory is enough because of the what do you call it? Because of the knowledge that has been built, is the goal just to retrieve information from the document. So you set the goal, but does it require planning? Does it require to use another tool? Are there any ambiguity? Then you talk of use AI agent. So determining and making decision on the framework to use to build your product is very important. And agent at this level is you build what we call a digital worker. Okay, that is your agent. Then there is an evolution of agent, right, where you have the single agent and the multi-agent. When we talk about single agent, is somebody being generalistic, right, where a generalist, like in the medical industry or sector, they have a general practitioner, somebody a general practitioner, or an MD who is versatile of anything. Whatever happened to you, they can check. But and then they also have specialists, right? So same thing, you think in that way, or what I call the AI agent swarm, or the multi-agent. So the generalist, so one massive prompt, one agent trying to do everything, maybe research, does coding, writing, review. It does all that, like you have today, like a generalist, right? Then we are now scaling to what we call the multi-agent. In other words, the swarm of agents. So a team of specialized agents orchestrated to collaborate together. You have a researcher, one agent is acting as a researcher. Even within that, you can have sub-researcher, because researchers have different domain, right, or different level. There could be senior researcher because of many years of experience, and junior researcher, even though in the same field, right? So there are testers, coders, writers. These are specialists. And so the advantage is that it now become modular, scalable, and each agent is expert in one thing. And what that means is that it provides higher accuracy, similar to project human being. When you have a task, depending on who you bring in a project, you have a project manager, you have a software engineer, you have cloud infrastructure engineer, different type of thing, that kind of team. Sorry. And so, builder's guide, let's provide some guide for you how to start. Okay. Uh, Today, if you have a product to build, AI product or agent, you have what we call, your mind comes to what we call a prototype, where you define the agent goal, the tool that are involved, the memory, and then you build your initial loop. Okay, you build your initial loop, and the kit too. The two kits here is your land graph or the LangChain land graph. You can use Microsoft AutoGen or even the OpenAI Assistance API to be able to build a prototype as of today. Then number two, there's what we call evaluate. Here we test for accuracy, we test for hallucination, because AI can also tell a lie. So you test for it. Is it has a tendency of lying or providing a very accurate output? And then we look at the loop limit and optimize the prompt. And here we use what we call the Landsmith. The toolkit here is the Landsmith. It's used to do tracing of your, and this tracing you are checking for accuracy, you are checking for hallucinations, and the limit to your loop limit, and probably optimizing the way you prompt. And then you also have the arrays phonims, that is for to do evaluations, and then the ragas, which is for rags matrix. You check the answers and all that. Then number three, you deploy. This is how to build, how to start. You can deploy. Then here you can containerize using Kubernetes. Either if you are using the AWS, you can use EKE, or Azure, you can use the AKS, or Google, you can use the GKS to run your Kubernetes platform. And then you do monitor in the productions and handle your state persistence in terms of either the tool here, you can use the Docker, the Kubernetes, the Celis, or to track your queuing for the event, and then the Redis for memory store. So there is a lot of things that you can do from time to time. Then we also have high impact use cases. Okay, for instance, we have agents that are being built today. You can build swarms, teams, multi-agent to do, and can make it an algorithmic trading swarms or agent, multi-agent. A multi-agent system where one agent analyze the news, the news sentiment, and then another check technical indicators, and a third one execute the trading. So you can use that to build a lot of things today, and 24/7 market coverage. You can build an agent to do trading, to do a lot of things, to check, to even advise you. We have a lot of all that, some of that today, even in Wall Street, that are out there. Then you can have diagnostics assistance. So agent that review, for instance, a patient history, cross-reference with medical journal, and then suggest potential diagnosis for doctor's review. And 40% faster than any other thing today. You can design that in terms of the agent. And then we have autonomous site reliability engineer or whatever. It's where you have agent that can detect server outages and then analyze log to find the root cause of those outages. I mean, the outages that happen, and automatically restart a service, or even do a rollback of code. And that can result to 90% less downtime in infrastructure. So agent can play. These are various use cases that you can build agent as of today, and many more. In fact, myself and my team, we build what we call Jericho AI, right? Which is the world first autonomous FinOps financial operation workforce. We don't just find it focuses on cloud waste, because like I mentioned today, to build, many of the cloud infrastructures are failing or going to production. Projects are failing as a result of the high cost of cloud infrastructure, right? Or either energy infrastructure or a compute infrastructure, or those type of things, even expertise as of this day. But what we have built, we built an autonomous agent, which we call autonomous FinOps workforce. And by the way, for those of you that are in Y Combinator, we have it listed there too. It is on Azure Marketplace. If you go to www.jerichoai.io, you will also see it. It identifies the wastages. So we have a multi-agent swarm of agents. Some act like a chief financial officer, FinOps engineer, DevOps engineer, business analytics, and then it does a lot of things. So, and this agent helps you to guarantee saving of your cloud costs across AWS, Azure, GCP, or whatever, up to 30 to 85%. And that's what we built using a different type of proprietary algorithm, and then those things. Then we have behave an autonomous way. Again, as I mentioned, is a multi-agent swarm that work 24/7 to optimize rate, price, infrastructure configurations, infrastructure usages, and then able to support that. And then we at back of it, which is like a backup, we have 100 plus vetted engineers, human engineers who are DevOps, that you can also call on demand to do migrations and stuff for you. So we call it World First. And in fact, the Swarm map, right? It has a financial squad. That is the Jericho AI, which has a rate strategies, optimize the rate, what the various providers are charging. It has a chief financial officer who check your budget and forecasting, and then the anomaly hunter. It detects the cost spikes. What is causing the infrastructure so much, your cloud infrastructure? So we can see we build a lot of that. And then it also have the engineering squad, like the Green Ops Guardian, which does resizing and cleaning, the cloud architecture, DevOps engineer, and different type of security sentinel, like check compliance, infrastructure design, and then all those things, right? And then, so the agent detect, it auto-fix, and then if the human engineer can even verify them, okay? And then we have business squad, like he has license auditor, vendor negotiator, project manager, different type of thing that we have built into this particular agent that we mentioned. And so there are common pitfalls why projects fail, especially in the AI industry. Number one is infinite loop, right? So agent getting stuck, repeating the same actions. We see that a lot. You can search on Google and see that. And so without finding an answer for example. So the fix is a missed iterations, like so. This is a big project problem. Why many of the projects are failing. And number two is hallucinations, right? So the agent confidently inventing to or data that doesn't exist to certify the prompt is another problem. And so fixing that today, we have RAG or other tool where we do schema to be able to solve that. And then there is a runaway cost, right? Runaway cost, right? So runaway cost, many of these projects fail because of the cost. And so multi-agent swarm passing huge contents windows back and forth, and then drilling API credits, right? So implementing context plurring and budget caps helps a lot. Then, of course, the security risks. So agent executing dangerous code, or leaking private informations like medical informations to an external API call can be dangerous. And so you can fix that by standbox executions and do like what we call PLL mapping, right? Or the PIL mapping, where you try to mask informations of end users. Then we also have future outlook that I really need you to understand. This year, 2026, we just starting. Today is 22nd of January 2026, you are going to see a lot of all these things that I'm talking about here, and even beyond. It's not now trending very well is the agentic IDE, where we have agent now programming like a computer program. And so imagine going to the university to read computer science or becoming a software engineer, and then agent, most of you have them. But what you need to understand, these agents are co-pilot, please, are co-pilot. And then coding isn't just a co-pilot anymore, actually, but agent can now write code, can debug, can deploy an entire future autonomously within the uh, integrated development environment, software development environment, the IDE. We see that Cursor, I don't know if you have heard of Cursor, even Lovables and different tools are there out today that can completely build a website by just talking to them. As we go into late of this year, 2026, I see what I call operating system level agency. That is the agent. And so here we are expecting, and I'm predicting that agents leaving the browser, they will begin to control your entire operating system. That is opening applications and then moving files and then mapping workflow. OpenAI operator, we see the Anthropy computer used today. Many of them watch out for OpenAI operator and then the Anthropy a computer. You need to watch out for them. And they are going to the level of operating system, be as a result of what I call operating system level, OS level agency. And then in the future, and probably late in this year as well, and going into the future, your keyboard becomes your mouth. You just speak and it begin to do a lot of things. So voice first one, where we see real time ultra low latency voice agent that can negotiate, it can books, it can coordinate. It's light of it is even happening right now. It can complete tasks, complex tasks over the phones, right? Or over various channels. You don't need human being agent will do that for you. And so we are really going to that level. And so join the builders. You can, if you have something in mind, you want to automate, you can talk to us and then we can build them for you, or you can work with us. You can get trained for us to build them. So what build what matters is very important for you not to fail. Build what matters. Weekly, we try to as much as possible to drop weekly stuff, right? So please visit our website where we drop an AI agent emerging workflow and future digital work. Don't just say watch the revolutions. You need to engineer it. Remember, build what matters. Don't just build here and there. So the key takeaway today is that agents, right? Chatbots talk, agent works. True agency require planning, to use, and ability to execute complex workflow autonomously. It's a key thing takeaway. Then orchestration is king. So the brain matters, okay? Matter more than the model. The orchestration is key. And I talk about the frameworks like the React and the rewards to manage your state and prevent chokes. And then we talk about starting small and scale fast. So begin with a single specialized agent. Once proven, you can scale to multi-agent swarm like Jericho AI for massive return on of investment. And so if you do have questions, let's discuss the future of your digital workforce. You can check on me on LinkedIn. You can ping me on LinkedIn. You can also visit our website to send an email. Remember that this, what we have looked at, is very important. You can always go over it, check over it, and begin to do something, because this is where the world is going. And any level you are, I don't need to be a computer scientist, an engineer to do anything. But everything is not AI agent. Please understand automation and then autonomy. Once again, it has been John Eno from MVIT. Have a very good evening.